What I hold in my hand is the promise of thousands of orbital space flights a day. What I hold in my other hand, strangely enough, is the promise of energy anywhere on the planet, deep geothermal. I'm Mark Russell. I'm the CEO and founder of EnergeticX, which actually you'll hear about how we split into two separate companies that are primarily owned by EnergeticX. There's Hypersciences, the terrestrial side of our company, funded by Shell and funded by Spokane and Seattle-based investors and some Houston folks, and then Pipeline to Space. A little bit on me, I'm an aeroastro engineer, undergrad from RPI, grad from Stanford University, and I'm a kid from about an hour east of here, Kellogg, Idaho, the home of the world's longest, deepest, and most profitable silver mines. So what you're going to hear today is a connection between industrial technologies for underground and aerospace. It's a pretty awesome opportunity to look completely novelly at a new technology developed at the University of Washington called RAM Accelerator. Dr. Carl Noland, one of the original inventors of this and a baffle tube technology, part funded between ourselves and JCATI to develop an awesome technology that we believe will game change multiple industries. So this is a paradigm shift. This isn't an incremental improvement. This is disrupting aerospace, transportation, things like tunneling for Hyperloop where you need 10 times rate of penetration for driving a tunnel, and energy, deep geothermal, anywhere. Again, we'll take you through our journey. But let's start with the problem. Traffic is bad. Seattle traffic's bad. We went and tried to tunnel bore to solve that. We ended up with a $2 billion hiccup. Tunneling's slow, it's dangerous, and it takes time. Oil and gas drilling, we're looking towards a carbon-free future, but right now we're dependent on chemical propulsion, chemical in our cars. Renewable energy, it's got its issues. We want 24-hour-a-day power. However, the sun does go down and you have to do other smart things like gum batteries and other things that we've heard of today that are part of the solution, but there are alternatives as well to that. Now, one that's near and dear to my heart. I was the lead engineer for Blue Origin's crew capsule development and the first vertical take-up and landing vehicle. We actually flew it out in Moses Lake. I know Boeing, you're going to do some testing out there. But when you're responsible for human safety and you look at the safety record of rockets today, even in the CubeSat market, which is an awesome growing market, and I hope all of you are thinking about flight systems in space, you work really hard on these payloads and you have a 1 in 20 chance of failure. This is just one example of many. I was part of a program called Boeing Sea Launch where we also lost our vehicles. So you have a 5% chance of your vehicle or your project not making it into orbit. Today, the good news is aircraft propulsion's super reliable. There's 30,000 takeoff and landings a day. Fortunately for spaceflight, there's less than 300 a year. It kind of speaks for itself. What is good about jet aircraft is they take chemical energy, turn it into kinetic energy, which goes into useful work. And you're going to hear that what I'm holding in my hand is actually the world's fastest, simplest hypersonic jet engine called a RAM jet accelerator. So when you focus your energy on problems using hypervelocity, it's a blue ocean of opportunity in both transportation as well as aerospace and deep energy. I'm going to play a short video of what we do with the technology that we've partnered up with JCATI. I'm very proud to show you some of these. So this is what it looks like when Mach 6 impacts granite. You don't need to drill and blast and you don't need to turn to the right. You simply direct your energy and you can break the rock fundamentally different, 10 times faster and 50% more efficiently. This is an example of our tunnel boring machine. Went from concept to operation. We're actually running this technology in our underground silver mine here in the Northwest. And that is firing these types of projectiles. And this is some of our nice clean laboratory work that we're testing out ways to very quickly change our parameters in our system, load it, and fire it, going from a manual operated lab into a very, very efficient automated system. You'll hear automated, autonomous,
Hyperdrill, harnessing the power of extreme
This is
velocity.
our hyper drilling system developed with cooperation with the Shell company for their game changer. We were able to demonstrate that we could drill 10 times faster than conventional rotary by one, driving a projectile made out of concrete into rock, and that rock fundamentally breaking differently than rotating, allowing us to go for deep geothermal energy under the planet, which is what we brought it to Shell to do. When you drill deeply and quickly, you are now able to affordably put geothermal on the planet. And this is pipeline to space. Again, Spaceport America down in New Mexico. This is our automated loading system where we take these payload modules and we load them into our flight vehicle and we fly them up using the RAM accelerator system as the primary means of propulsion. Here's some test data from our June flight of our baffle tube RAM accelerator flying at the spaceport. And the idea is to recover those payloads, bring them back for suborbital, growing into an orbital program where you're flying thousands of times per day. Okay, so we're taking the problem, which is your small payloads. Think of the UAVs in space. These are the CubeSats. They're secondary payloads, tertiary, they're afterthoughts. What we're doing is solving that bottleneck, delivering your important payload when you want to fly it, and doing it very reliably and robustly on demand. Fundamentally works different than a rocket. We eliminate stage one. We are flying from the spaceport up through a tube. RAM accelerator is very simple. You have natural gas and air in a tube, and as it flies through the tube, it creates a wave, a shock wave. Just like a surfer riding a wave in the ocean, it flies through the tube and exits at multiple times the speed of sound. In fact, about 1/3 orbital velocity. We point that sideways, and our projectile separates from its case, and now you have a much smaller orbital insertion. Eliminating all the fighting with drag and fighting with gravity, you have a very simple lofted orbital insertion, decreasing the cost of this by 5 to 10x and increasing the flight rate by 1,000x. We don't just talk about it and draw cool pictures. We actually have this testing, again, in our mines up in the Northwest here, as well as down at Spaceport America, south of Albuquerque. So the University of Washington and JCATI, we partnered together and used the RAM accelerator as our primary propulsion. Again, simple chemical energy to kinetic energy to useful work going into orbit. It's super industrial, it's scalable, and this is what we call our hypercore system. And that's what we're out today with industry partners who want to use this for both tunneling as well as for flight. What is a vending machine doing out in the middle of the desert? Well, that's how we think of space flight. Rather than onesie, twosie, this is your app store for space. You decide what you want to put into orbit. You send it to us, you FedEx it, or you come down and fire it with us. But it's loaded and locked in. There's hundreds of them ready to fly. Just another image. This is one we have actually just down the street. This is using our automated loading system for the industrial applications. Again, hypercore. Again, tunneling at 30 to 50% lower cost and 10 times faster. Not just an idea, but we actually go out, fire it, and fly it. Really, I'm passionate about terrestrial use of this as well as the space flight use. Being able to access deep energy. We live on a planet that has a thermonuclear reactor underneath of us. It's just a matter of gaining access to that heat affordably. And that's what Hyperdrill offers, is to get down to deep energy quickly, and that way you can afford to operate it. You cannot afford to get to deep geothermal quickly with today's rotary technology. So this is the last slide. Our roadmap is simple. We do the near surface flying at Spaceport America and the tunnel boring, hopefully enabling groups like Hyperloop and other technologies that want to transport people on this planet. we move over to the spaceport and we're starting to fly regularly. And as we grow in our shot count and opportunities in the energy come together in the next few years, where we've solved some of the other parts of the geothermal problem, bringing that fluid up between different wells. So we have a lot of work to do, and we're looking forward to working with JCATI and universities, WSU, and Western Washington, UW obviously, and other students that really want to bring their mind to the problem to solve really hard ones. So let's make a meaningful impact, all puns intended here. So Mark Russell, Pipeline Space, Hyper Sciences. Thank you.